Greetings, welcome to the video for Lab 2. So if you have not yet done so, I need you to go and do a couple things for me before we start here. First off, you need to go and download the actual lab. That's this link right here. You obviously found the link for the video or you wouldn't be watching this. And you probably should get the assignment 3 template opened up also in our studio. So if you haven't done that yet, take a moment and go back and do that. Now once we finish the lab, of course, what you're going to need to do is click on the tab for exercises and go on and continue on in the RMD file for the assignment 3 template and do your actual exercises in there. But for now, we're going to focus on the lab. So we'll click on the Lab 2 and we'll open up a new tab for us. And we see Introduction to Data Part 2, Getting Started. So we're going to take a look at the Behavioral Risk Factor Surveillance System data set that we looked in our previous lab. And so we're going to need to go back in and one more time load that CDC data right here. We'll go ahead and highlight that. Be sure and include the word source. We're going to copy that. We're going to go into our studio here and we'll go into our console. Let's go ahead and clean our console up. If you hold down the control key and hit an L, it'll give you a brand new console. And we'll paste that in and we'll hit an enter. Okay. Now notice a little stop sign came up, so we're going to be here for just a minute while it loads the data because there are 20,000 data points in there. So while it's doing that, let me explain to you what we're going to be doing in this lab. What we're going to do this time is we're going to take a look at some very powerful R commands that allow us to take a data frame and parse out of it just the parts of the data that we're interested in. So if you recall, if we come over here, if you go into your environment and you click on CDC, if you recall, a data frame is basically a matrix or a spreadsheet. And what it has in it is has data, which are in the rows, and then the columns represent the different variables that are in there. So for example, if I want to know what the dimensions of this particular data frame are, I can type in dim, and I can put in CDC, and it'll tell me that there are 20,000 rows by 9 columns here, which means that there are 9 variables inside of this this data frame. Now in the lab it says if you want to find the names, you can put in names CDC and it'll give you the list of the names. But one of the nice things about working in our studio is we're actually able to open up the data frame and take a look at it so we can see the actual variables here. But the thing to notice about the 9 is that there are 9 variables. So that's 1 is general health, 2 exercise any, health plan is 3, smoke 100 is 4, etc. So when we talk about these numbers, if I want to say, for example, direct you to row 8, column 2, that would say that I would have yes for a health plan for that particular individual. So by giving the row and column number, I can direct you to a specific element within this spreadsheet or this data frame. Okay, so what if I wanted to gather up the weights of just the first 10 respondents? So say I came in here and I just wanted to get these first 10 data points. So these numbers right here in this column, I want to grab the first 10 of those. Well, to do that, I'm going to use what's referred to as the square bracket notation. And the bracket notation is very powerful notation. What it does is it goes in and it grabs just specific elements from the data set. So for example, let's go get just a single element first. Let's go get the 567th weight, okay? And the reason I know that 6 is the weight is because I go 1, 2, 3, 4, 5, 6, right? So the 6th data element is weight. I hit an enter, and if you scroll down over here, I'll let you do it if you'd like, and you get down to 567 on your row number and go over to weight, you'll see it was 160 pounds, okay? All right, well, what if, like I said earlier, I wanted to get the first 10 of those weights? Well, I can again go CDC, and now use the square bracket notation, and I can go 1:10, comma 6. So that says, give me the first 10 from the column 6, which is weight. And so that gives me back the first 10 data points from there. So quick aside again on the colon notation, the 1:10, what that does is it gives me the first 10 numbers. Very interesting command. I can put 10:1 and notice it'll count down for me. So that's a very useful tool when you're looking to create a list of numbers, particularly when you're searching through a data frame. Okay, so what if I wanted to get the first 10 respondents for everybody, for the entire data frame, okay? Well, I can type in CDC, square bracket, 1:10, comma, and then leave the variable field blank. And when I do that, it's going to give me the first 10 of everybody. So the first 10 of good health, first 10 of exercise, any health plan, etc. In other words, by leaving this blank right here, in other words, leaving the variable number blank, it says I want all of the variables. So give me the first 10 entries in all 9 of my variables is what it did there. Okay, so what if we want to go the other way around? What if I wanted to get all of the weights? Well, to get all the weights, I can go CDC, square bracket, leave the row number blank, and give it the column. And so by doing that, it's going to spew, well, in our case, only 999 of them, roughly, of all of the weights from our data set. Okay, so that can be very powerful. It's actually a nice way to quickly gather up stuff. So go ahead and hold down your control key and hit the L again, and that'll clean up all that mess in our console. Now, that command, let me just type it in here one more time for you, CDC square bracket comma 6 is actually equivalent. That right there is equivalent to if I had gone CDC $ weights. Notice I'll get back exactly the same thing either way. So those two commands are actually synonymous with each other. It just turns out that using that square bracket sometimes is very advantageous to us, and we want to get good at that. So when you will use one versus the other will be pretty much, pertains upon what it is you're actually looking for, at the moment. Okay, one more time on cleaning our console because we don't want all those numbers in our face. So the nice thing is by using that $ notation is I can go in and pick out just a single element. If I want to go grab just a single element from the data set, I can actually use the $ notation instead of giving it the row and column. So in other words, I can say CDC $weight, and then I can say I would like the 567th data point, and it comes back 160, just like previously we had told it that we wanted to go into the CDC data set and get out just a single value, in other words, a single value from the weight by putting in CDC 567, 6. So just remind you real quick that again is equivalent. I could go CDC 567. Remember, the 567 is the row number, and then the 6th column, which is the weight, and I get back exactly the same thing. So it is a synonymous command again. And again, you'll find that those get used off and on. Both the $ notation by itself and the square bracket notation by itself get used depending on the situation, exactly what you're working with. Okay, so let's take one more look here at a synonymous, and then we're going to go forward and start working on the subset command. So we could have actually gone CDC $weight, and we could have said give me the first 10 in there, 1:10, and notice that gives me the 10 weights, which is the same thing as if I had said, as we did earlier, CDC square bracket 1:10, and I want it for the weight column, okay, which is column 6. And notice I get the same numbers. Okay, let's switch gears here for a moment. I want to go back to algebra for just a moment. Yes, I can hear you all saying boo, but we're going to take a moment. We're going to go back into algebra, okay? So let's go back to algebra for just one moment here, and let's take a look at, let me get a paint screen up for you here, and let's take a look at a command back there, or a type of notation back from algebra that was referred to as set builder notation. So sometime in your algebra experience, you should have seen the following type of notation, okay? So let's get over here. Get my pen going here. Here we go. All right. So set builder notation. If you recall set builder notation, it was a brace. That's a brace. And it doesn't look like it. You'd open a brace, and then you would put inside of the brace what the typical element was. And then usually there was a colon here, which was read as such that, and then there was some sort of condition to be a member of the set, like say x was greater than or equal to 3. Okay, so you may remember seeing that notation, but let me just remind you how what each of those pieces mean again. So what all of that means. So this right here, that open brace right there, that says a set of. A set of, okay? Well, what is it a set of? Well, the next thing is, what is it that you want to get that set made of? What are the things that you want to get from there? So what are the elements of the set? So in other words, what you're doing is you're telling your viewing public where to go get the members of the set from. They all belong to this, whatever these things are x's, okay? And then the colon here, the colon is read as such that. In other words, we're about to tell you some sort of a condition to be a member of the set. And then this is the actual condition here. There's some sort of logic here. There's some sort of logical statement that gives you the condition of the set. And the condition, what it says, what I mean by condition is what is it to me a member? What qualifications do you have to be a member or to be in the set? All right, now it turns out that R has a very equivalent sort of notation to it. It's called subset. And subset, the subset command, works almost identical to set builder notation. It's very, very similar. So the first thing on subset that you have to give it is something that you want it to act upon. So this element, right? Okay, this item, I'm going to call it an item here just to change the vernacular just a smidge here. So this item right here, this can be a variety of different things, but for our notation, for our work, that typically is going to be either a data frame or a vector. For the most part, it usually will be a data frame. That's going to be, for our work, be the most common thing that we'll put in there, but we will also use a vector. Actually, even in this lab, we will show how we can use this on vectors. So what it is again, as back up here, when we're talking about with the elements of the set, it's where am I getting my stuff, okay? So where am I going to? Where's the bucket which I want to grab things out of? Okay, then once we're done with that, we're going to have a comma. The comma can be inferred as to the such that. So the such that and the comma here basically are synonymous. And then you're going to have some sort of logic. And that logic is going to be what determines what the members of the set are going to be. In other words, it tells you how to parse them out. So for example, this is just kind of a crude example to sort of see what we're doing here. I could say subset CDC, so that's where I want to go get my data from, comma, and I could go CDC $, weight greater than 160. And what that would return, what R would give me back then, are all of the columns and all of the rows that are connected with a weight greater than 160. Okay, enough yakking about this. Let's go do it. I think it's going to make a lot more sense if we put the rubber to the road, so to speak, and we actually go work a little bit, okay? So let's go play first of all just with the logical statements so we can see how those work, and then we'll take the logical statements and we'll wrap them into a subset. So let's say we said CDC $gender, and I put in the double whammies equal, which is the equivalence notation. Okay, that's not an equal sign. Notice that's not an assignment. That's a logical statement that says that this is equivalent. So give me all of them that are equivalent, and since it's a character variable, I need to put in quotes, and so all of them that are m's. So if I hit an enter, it's going to give me a display of trues and falses. So what the heck are these trues and falses all about? Well, what it just did is it told me every one of the data points within the CDC gender that were in fact males. And if they were males, it came back with a true. If they were females, it came back with a false. Okay, so let's take a look here. See, the first one we got a true, so come back up here. Notice that the gender was a male. The second one we got was a false. Notice that the gender was a female. Then it was a false, and it was a false. Those are all females, and so forth. And the next time we see a true was the next time we see a male. Then we got true, true, etc. So in other words, what this command did is it basically was a logical command where it returned a true or a false. True meaning it was a male, female for the false, or that it was not a male, either way you want to look at it, okay? All right, now when R looks at trues and falses, those are very valuable because trues, it means I want it, and false means I don't want it. Keep that in mind. A true means I want it, false means I don't want it. Let's take a look at another one. What if I said CDC, and now we'll do a numerical variable here. Let's say I'm going to look at the ages, and I want all of the ages greater than 30. And again, it's going to give me just a whole list of trues and falses. Let's come back up to the top here so we can kind of compare it back with our data frame. So if we take a look at the ages in our data frame, so look, that's greater than 30, greater than 30, greater than 30. We've got a whole bunch of trues until we get down to the 27, which is a false, right? So that was the ninth one, and if you count over 9, you're going to see that that's the first time that you come across a false. All right, hopefully that's starting to make some sense. Let's go ahead and clean up my console here, get all this nonsense out of the way. So what I would like to do is I would like to go in, first of all, and I would like to make a new data frame. And the data frame I want to make would be just the males. So to do that, I can go male data, or mdata. This is just a name. It's the one that they chose to pick in the lab. And then the men's data, I'm going to make that equal to, and now I'm going to use my subset command. And so subset, first thing I got to tell it is where do I want to go collect these information. In other words, what was the big set that I want to subset from? Well, the big set is CDC. Now such that, that's my comma, and I'm going to go CDC $, so the gender, double whammy is equal to male or men. Okay, when I hit an enter now, and I come back over here and I take a look in my environment, notice I just created a new data frame that has roughly, half, about a little less than 10,000 of the folks that were actually males. In fact, if I click on that and I open it up, what I'll see now is that this data frame, all of the genders are males. So I was able to segregate out all of the males from the CDC data set. I created a new data frame that has nothing but males in it, okay? So you can use the head command like they say in the lab, or you could just click on the view, which is really actually the nicer way of doing it. Okay, so what if I want the men that are over 30? What if I want to make myself a data frame that have the men and they're over 30? Well, there are two logical connectors. So let me show you those as in the logic first, then we'll put them into the subset. Okay, so if I want the gender to be equal to male and the age to be equal to greater than 30, I can say CDC, let's come back over here, CDC gender, double whammy equals male. And now I can put in the logical connector and. In logic, and means both conditions have to be true in order for you to get a true. So the and is the ampersand. It's above your 7. And I'm going to put in here CDC age is greater than 30. Okay? And when I do that, again, I'm going to get a whole bunch of trues and falses. But this time, it's only going to give me a true when both conditions are met. So let's take a look at our first entrants here, okay? So the first entrant, the age was 77 and it was male, so we got a true. In the second one, the age was, my bad. I'm looking in the wrong data set. Hang on a sec. Ooh, I was getting a little confused there, but then unfortunately I got my brain back. Okay, here we go. And the second data set, it was 33 and it was female, so we got a false, right? And then the third one is 49 and female, so we got a false. So notice the ages were greater than 30, but they were female, so that's going to come out false. Both conditions had to be true. They had to both be a male and their age had to be greater than 30, okay? All right, so now the nice thing about that, let's clean up our console again, is that we can put that into the subset command and it will parse out of our data frame for us all of the elements that meet both of those conditions. So we're going to go male and over 30. And we're going to put an equals here. You can use the left assign if you'd like. And we're going to type in again the subset command. And we're going to put in CDC. As it turns out, you don't need to use the CDC $ gender because you told it that the set you're getting it from is CDC. So we can speed things up a little bit and just put in gender. On the other hand, if you want to put in that $ just to be super safe and remind yourself, that's good. That will definitely, in the long run, not be a bad idea. Okay, so now look, I put in gender. So first condition is that the gender is equal to male. And now I put in the ampersand for the and I got to put in that the age is greater than 30. Okay, and again, if you decided to put in CDC $gender and CDC $age, it would have worked out exactly the same. Okay, so now when I hit an enter, notice a new data frame just pops up over here in my environment, and if I click on that and take a look at that, notice that these are all the genders are male and all of the ages are greater than 30. So I have created a data frame now that has the characteristics of that it's just men and it's just men over 30. So that's really powerful stuff. You might want to take a moment and just digest what we just did. Try and do that on an Excel spreadsheet. That's not simple, okay? Many data frame, data management systems will have queries that allow you to do those sort of things, but it's very, cumbersome to get those done in simple programs like Excel. Okay, anyway, back to the ranch here. So there's another logical character, the or. The or command says it's this or that or both. So if you meet either one of the conditions, if you meet the first condition or you meet the second condition, you get to come along and play with us, okay? So let's make a new data frame based upon the word or. So it's this or that or both. So again, we're going to do men or over 30 this time. And if we do men or over 30 this time, again, we're going to use the same subset command. Subset is really your friend. This is probably, of all the R commands we're going to teach you this semester, this is one of the most important ones. So CDC, that's where we're going to go get them. So again, its gender is going to be equal to male. Okay. But now, if you go and take a look right above your return key, you'll see the / and the second function on your / you hit the shift key, is going to be the vertical line. That's the bar. That bar is the or. So if I'll read this to you here as soon as I finish typing it. So the way you would read this, it says subset. So it says, give me the set of elements from CDC such that the gender is male or the age is greater than 30. See if you can do that yourself. Stop for just a moment and see if you can reread that and have that make sense to you. Okay, so now I run that and let's see. Let's go ahead and take a look at that. Let's go ahead and actually display that data set, okay, or that data frame. So we'll click up over here and let's see, what do we got? So this is men and over 30. Oh, wrong one, sorry, I'm going to click on or. Men or over 30, that was the one we wanted. And if we click on that, notice that if either one of the conditions is true this time, either they're men or they're over 30, they're going to be in there. So there's going to be some females in here also because it's either one of the conditions. So if you're over 30, see here's a female who was over 30 years of age. So she's included. Or if we scroll down, we will find some men that are less than 30 years of age that are in there because it was either one of the conditions are true, you're going to get included in the data frame. Okay, hopefully that logic makes sense to you. If you need more help with that, let me know and I'll be happy to go through and work some stuff to help you out with that. Okay, so now what they want us to do is they want us to come in just to kind of give us a heads up on what's going on your own, and they want us to create a new object called under 23 and smoke. Okay, so let's do that. So under 23 and the smoke. Oh, bad, bad, bad. If you smoke, please stop. I implore you. I want you guys to stick around. You need to help make this world a better place, okay? That contains all the respondents under the age of 23 that have smoked 100 cigarettes in their lifetime. Write the command you use for this as an answer to this exercise. Okay, so let's see, under 23 and smoke. So we're going to need to make another subset. So what should we do with the subset? Well, of course, we're going from the DataFrame CDC, so we'll go CDC, comma. All right, so now let's see, let's think about this. Now they got to be under 23. So if they're under 23, then that means that the age has to be less than 23. And now they have an and. Okay, so that's an ampersand. So that's the character above the 7. So shift 7 to get that. And smoke. Let's see, what was the smoke? So smoke 100. Well, let's see. We got to go check out the smoke 100. What are the variables there? They're either a 0 or a 1, right? And so the 1 means they smoked. The 0 means that they did not smoke. So we're going to go smoke 100. Double whammy equals, and we'll put in a 1, okay? And so if we hit an enter, and we come back over here and we take a look at our new data frame that we just generated, notice that all of the smoking is going to be 100, and all of the ages over here are going to be under 23. So these are the folks we really want to target with our ad campaign to say, please stop smoking because we want you around. We don't want you to hurt yourself, and by smoking you're going to be hurting yourself. Okay, on your own now. We're switching to the on your own. And so on the on your own, we're supposed to take some of our new tools for a stroll to go see if we can make them work. So the first thing that they're going to ask us to do in on your own, so I'm going to switch over to the RMD now because they want us to do these in our lab, okay? So the first thing they want us to do is to come in and actually generate a new data frame called fem, where we've gone in and taken all the females. Okay, you could have called it F data if you wanted to, but I chose to call it fem for female. And so they did a CDC, comma CDC gender equals female. Now again, you could have left this part out and it would have been just fine. It could, if you just put gender equals in quotations female, it would have found it. All right. And so when you take a look at that data set, if you look in the lab here, let's go ahead and go back over to the lab. Into Chrome, if we scroll down here, and you see that what we've got is now, this is again, as was in the previous examples, this is a data frame containing just females. And then if you go in and you do the dimensions command, you'll get back when you knit this, it'll tell you that there are 10,431 rows and there are 9 columns. Okay, so that means there were 10,431 females in the CDC data set. Okay, so one of the things that we can do is we can go in and get out of there a single column of data and we can store that. So we can take the female heights and we can store those into a data set. So let me come back here for a moment to the, let me get to the right spot for you. Let's take a look at the fem data frame. Let me go ahead and click on that so we can see it here. If I want to get the column with just their heights, notice that's the 1, 2, 3, 4. That's the 5th variable. And since that's the 5th variable, if I want to get and store those into a single vector, I can go FH for female height. And we'll come down here and do it in the console for you just to show you. I can go FH is equal to fem from the data frame, square bracket notation, leave a blank because I want all of them in the 5th column. In other words, the 5th column of data. And so what that does now is that puts into female heights all of the heights for the females. In fact, if you just type in and have FH, go ahead, let me open this up just a bit for you so you can see here. If I have FH return to the console, you can see that these are all just the heights and inches of the females in my data frame, okay? All right, one of the things that's good to know is what the length of that vector is. So it's not the dimensions. We could use dimension because it'll give you back a 0 on one thing, but length is a really nice command also, okay? So if you use length, it's the length of a vector, and I can say, give me the length of the female heights, and it returns back 10,431, which is what we knew. We knew that there were 10,431 females in here, so we would expect 10,431 heights, okay? All right, so now it's your guys' turn to do a little bit of work. I'm going to turn you loose on the exercises. There are basically 9 more than that you need to do. Don't be shy about posting questions to the question and answer forum, asking how to do these problems. I'm happy to help you. And don't forget, we have the online office hours also at your disposal to help you out.